Yes. Hello everyone, this is D. Chinnagokari. Welcome to our chemistry channel, Chemistry Masters Academy. So in this video lecture, I am going to explain about the IUPAC nomenclature of hydrocarbons without any functional group. Okay. So in previous lectures, I have explained what is the classification of organic compounds and introduction of organic compounds and basic structure of IUPAC nomenclature. Okay. So here I am going to explain nomenclature of aliphatic hydrocarbons without any functional group. Okay, so here any IUPAC name contain following parts, that is secondary prefix, primary prefix, root word, primary suffix, secondary suffix. So here secondary prefix, it gives information about the substituent. Substituent means which is not included in the longest carbon chain. Next, primary prefix, it gives about the nature of carbon chain, whether it is open chain or cyclic, bicyclo, spiro. In open chain compounds we are not going to write any other prefixes. And root word, here what is root word means, root word gives information about the number of carbons in the longest carbon chain, like meth, eth, prop, but, pent, hex, hept, oct, non, dec, undec, dodec, like that. Next, primary suffix. Primary suffix gives information about saturation or unsaturation. Saturation means carbon chain contain only carbon single bonds, that is called saturation. And unsaturation means if carbon contain double bond or triple bond, that is called unsaturation. When it is saturated we use in, when it is unsaturated we use in and ein. Okay, in for double bond, ein for triple bond. And the secondary suffix gives information about the functional group. Okay, so here we are discussing nomenclature of aliphatic hydrocarbons, open chain compounds without functional group. Open chain compounds means here there is no need of prefix and there is no need of suffix. Prefix cyclo, bicyclo, spiro, and functional groups, the different functional groups names are there, we'll discuss later. But here these two parts are not required in the IUPAC nomenclature. Okay, now first, so now let us see what is the structure of IUPAC of such type of compounds, that is secondary prefix, root word, primary suffix. Okay, so now let us discuss how to name these organic compounds, aliphatic hydrocarbons without any functional groups. Okay, so for any nomenclature we have some set of rules. So here we are going to learn that set of rules, and slowly we are going to learn how to give the names. Okay, first, longest chain rule. So longest chain rule means having more number of carbons. We should select the longest chain or parent carbon chain which is having more number of carbon atoms. See, in this example, when you observe from left to right, when you go here 7 carbons are there, and left to here, after this when you are coming to here, you are having 6 carbons only. Now this will become the longest carbon chain. And in the second example, here we are having 7 carbons, and when you number in different direction, 1 2 3 4 5 6 7 8 9, like that continuously only we should give the numbering. Okay, so when you are coming in this direction you are getting 9 carbon atoms. So now it will be the longest carbon chain. Okay, so now what we can get one conclusion here, longest carbon chain need not to be a straight chain. Longest carbon chain, longest carbon chain or parent carbon chain, longest carbon chain need not to be a straight chain. Straight chain. But what is the rule means here, we should give number continuously without any breaking. Okay, like 1 2 3 4 5 6 7 8 9. Okay, that is the rule is there. Next, After this longest chain rule, we should give numbering to the longest carbon chain. Okay, this is about the selection of longest carbon chain. Then after we should give numbering. Okay, so here is here we'll write. So next, first rule is finished. That is longest carbon chain rule. First one, longest carbon chain rule finished. Next, numbering. This is also called lowest sum rule. Okay, numbering or lowest sum rule here. So after selection of the longest carbon chain, we should give the number for the carbon numberings for the carbon atoms. Why we need to give the numbering for the carbon atoms means to locate the position of substituent. Okay, see, for example, carbon, likewise we are going to have the this type of carbon chain here. 1 2 3 4 5, these 5 carbons are included in the longest carbon chain, and this carbon is not included in the longest carbon chain. Now this will become as the substituent. So what is the meaning of substituent means? Which is not included in the longest carbon chain, that is called what? Substituent. So to locate this substituent only, we are going to give the numbering. So how we should give the numbering? So here, lowest locant to the substituent means when we are having only a single substituent, lowest possible number we should give. For example, we are having a carbon chain 1 2 3 4 5 2 3 4 like that. So this is one carbon chain. So here, when you observe clearly, so the longest carbon chain or parent carbon chain is, first select the longest carbon chain. 1 2 3 4 5 6 7 8, 8 carbons are there. Now when you go from this direction, 1 2 3 4 5 6 only is there. So how many carbons are present in the longest carbon chain means 1 2 3 4 5 6 7 8, 8 carbons are there. Okay, and here let us add one more carbon, 9. So 9 carbons are there. So this is the longest possible chain. So here we can give the numbering from either directions, but which direction is correct means where we are getting the lowest number for the substituent, that is the correct way of giving numbering. Okay, so now let us give from another direction. So before that, let us have clarity. This carbon is not included in the longest carbon chain, so it is the substituent. Okay, so this substituent must get the lowest possible number. Okay, so in this direction, here we are getting number 4. Let us give from opposite direction. 1 2 3 4 5 6 7 8 9. Okay, so here from this direction it is getting, okay, let us write it. So from this direction it is getting carbon substituent have substituent have fourth position, and in this direction substituent have sixth position. So now which one is correct here? Means the lowest number. Lowest number is, this is the correct one. Lowest number. So in this direction it is getting the lowest number. So it is correct. But this numbering is wrong. This numbering is correct. Why this numbering is correct means here substituent is getting fourth position, but here substituent is getting sixth position. That's why this numbering is wrong. This numbering is correct. Next, when we are having two substituents, okay, whenever you are having the single substituent, there is no confusion. Whenever you are having two substituents, then how to give the numbering? So when we are having more than one substituent, we should give numbering according to the first point of difference. So when we have more than one substituent, more than one substituent, we should give numbering according to first point of difference, first point of reference. We should give numbering according to first point of preference, okay. So previously this rule is known as what? Lowest sum rule. Okay. So lowest sum rule. So now let us get the what is the difference between lowest sum rule and first point of difference. This point is very, very important. Okay. So observe very carefully. So carbon, let us take the carbon, this is the carbon chain, and here we are having substituents. Okay, let us take one more carbon. So here we are having the substituents. Now let us give the numbering. Let us number these substituents. Okay, numbers 1, 2, 3, 4, 5, 6. So in this direction we are getting the position of substituents 2, 4. Okay. Now let us give the numbering in another direction. 1, 2, 3, 4, 5, 6. So in another direction we are getting the numbering 3, 5. Okay. Now compare the positions. So here in this direction we are getting the substituent at second position, and in this direction we are getting the substituent at third position. Okay. So now in which direction we are getting the first number is less, that direction is correct. That is called what? First point of preference. Means in this direction it is 2, but in this direction it is 3. No need to add this and add this here. Add 2 plus 4, that is 6, 5 plus 3, that is 8. So this is correct likewise. No need to do this, but just you compare the numbers. From this direction, first where you are getting substituent, second position. In this direction at third position. So where we are getting the less number, that is the correct numbering. And according to lowest sum rule also, this is only correct. Why? Because the sum is 6, here sum is 8. But we are having some more compounds. where we get the lowest sum rule wrong. Okay, so here when you observe, the lowest sum rule give 99% correct only, but in some cases it will give some error, but first point of difference will give correct idea about the numbering. For example, let us see one more example. Let us take one more example here, you can get one clarity. Okay, I'll take carbons. Carbon chain I am going to take. Okay, so now let us consider, here we are having a substituent and here we are having the substituents. Okay, now number this. Let us check the first point of difference and lowest sum rule. Okay, so now number this 1 2 3 4 5 6. So here what is the position of substituents? Second position also one substituent, fourth position two substituents, 4 comma 4. Okay, so in another direction let us see the numbering in another direction. 1 2 3 4 5 6. Okay, so now let us see numbering here 3 comma 3 comma 5. Okay, so now let us sum up this. So here 4 plus 2 6, 6 plus 4 11. Okay, sorry 10, and here 3 plus 3 plus 5, 6 plus 5, it will be 11. So in this case which one is the correct one? Lowest sum rule. According to lowest sum rule, this is only correct. According to first point of difference also, this is only correct. Why? Because here 2 and here it is 3. Okay, but so let us take one more example, one more case. Let us observe. One more example we will take. Okay, okay, so this is the substituent and here you take the substituents, carbon and carbon. This is the substituent. Okay, so now give the numbering. Give the numbering 1 2 3 4 5 6 7. Okay, 7 carbons are there, and what is the position of substituents? 2 comma 5 comma 5. Okay, so now let us give the numbering in another direction. 1 2 3 4 5 6 7. Okay, so now write the position of substituents 3 comma 3 comma 6. Okay, so now what is the sum of this small sum of this one? 5 plus 5 10 12. So here also we will get 3 plus 9 9 plus 3 12. Okay, you are going to get like this, right? Okay, so now what is the lowest number? Here equally is there. Okay, this is one different condition. Then that time which one we should select, this or this will get confusion. That's why we follow the first point of preference. According to first point of preference, this one is correct, this one is wrong. Now let us take one more situation. Okay, let us take one more situation. Carbon. So now in this time I am going to take 9 carbons. Okay, So now let us have a substituent here. Okay. And two substituents here. Means this is carbon substituent, carbon substituents. Now let us give the numbering. Number these substituents: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So here what is the position of substituents? 2 comma 8 comma 8. Next, in opposite direction, when you see in the opposite direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now what is the position of substituents? 3 comma 3 comma 9. So now which one is correct? So now let us take the lowest sum rule. 2 plus 8 plus 8, it will become 18. And 3 plus 9, it will become 15. So now according to the lowest sum rule, which one is correct now? According to the lowest sum rule, this second one is correct, but this is wrong according to lowest sum rule. Lowest sum rule, this is wrong. Means this is correct, this is wrong. But actually, which one is correct? According to first point of difference, what we are going to check first, what is the position of substituent? Second position. Here what is the position of substituent? Third position. So this is the correct according to first point of preference. First point of preference. So here first point of preference is always correct, but whereas this lowest sum rule 99% correct, but in one case it will give the wrong result. That's why it is better to follow the first point of difference instead of the lowest sum rule when we are having the more than one substituents. So first point of difference, it is nothing but just we write the position of substituents in which direction we are getting the least position first. That is only the correct way of giving numbering. Okay. Next, let us take some more examples. Let us take some more examples. Okay, to understand this first point of difference. Carbon. Okay. Second position. We are having one more second position, and here third position. So now let us write the position of substituents. So in this direction, let us give numbering: 1, 2, 3, 4, 5, 6. Okay. So now position of substituents: 2 comma 2 comma 4 comma 5. In this direction, let us give in this direction also, opposite direction: 1, 2, 3, 4, 5, 6. So in this direction also we are having second position substituent. Next, fifth position, sorry, third position. Next one is the third position. Next, fifth and fifth. So now in this one, which one is correct? First we are comparing these two numbers. These two numbers are same. Next, go to the another two numbers. Okay. So here we are having the lowest number. That's why this is only the correct according to first point of preference. Okay. This is about to first point of preference. So this rule is very important. First point of preference is very important. So blindly if you follow the lowest sum rule means you might get the wrong answer. Okay, you may get the wrong answer. Okay, right. So now let us write the name of some organic compounds by using these two rules only. Okay, these two rules only. Okay. Okay. Now, before writing the IUPAC names, first let us know the name of substituents. Name of substituents. Substituent, substituent, prefix. Substituent and prefix. For example, chlorine is substituent or halogen is substituent. Halogen. X. Prefix is halo. Which prefix? Secondary prefix. Halo means here chlorine, chlorine, bromine, iodine. So these are the halogens: chloro, fluoro, bromo, iodo. So even though these are act as functional groups, but IUPAC is considered as the substituents itself. Next, NO2. This is nitro. NO, nitraso. Okay. Likewise, next N double bond N, azo, azo compounds. Next ROR, alkoxy. Okay. Likewise, alkoxy. This is ether actually. It is here. It is also included in the substituent. Next R, alkyl. R is the alkyl. So what is alkyl here? Okay, alkyl means, so we know alkane, right? Alkane. Alkane general formula CnH2n plus 2. This is alkane. From this, here we are going to remove one hydrogen and we are removing one N and we are adding il. This will become alkyl. Okay, so CnH2n plus 1 is called alkyl. Okay, here alkyl is the substituent. Okay, example for the alkyl substituents. Example for alkyl substituents, CH3. This is methyl. Okay, or else you see CH4 is methane. CH4 is methane. So from this CH4 we are removing one hydrogen and minus N and we are adding il. Okay, so now CH4 is the methane, whereas CH3 is the methyl. Methyl. So sometimes it is represented as Me, methyl. Next C2H6. C2H6 is the ethane. So from this we are removing hydrogen N and we are adding il. So this is the ethane. So C2H5 is called ethyl. Okay, so it is represented as sometime Et. Et means ethyl group, like propyl. C3H6, C3H8 is the propane. From this here we are removing hydrogen and we are removing N and we are adding il. So that will become C3H7, that is propyl PR. Okay, these are the names of the substituents. Sometimes alkenes are also will be substituents. In the case of alkenes, unsaturated hydrocarbons, when alkene is substituent, here also we are removing one hydrogen and we are removing N, we are adding il. Not in here, we are only removing E and we are adding il. Okay, so now the substituents will become alkynyl. Okay, alkynyl. Then when alkynes are substituents, here we are removing hydrogen and we are removing E and we are adding il. So alkynyl. So these are the some examples of substituents. Okay, so now let us use the name of these substituents. So these are actually the simple substituents, and complex substituents also I will discuss after the discussing some names here. Okay, right. Okay, so here how to give the IUPAC nomenclature of aliphatic hydrocarbons. So what are the rules? Let us scrutinize the rules. So first one is longest chain rule. First one is the longest chain rule. Longest chain rule means more number of carbon atoms. More number of carbon atoms. Okay. Next, lowest locant rule. Lowest locant rule. Lowest locant rule, which means we should give the less number to the less possible number to the substituents. Less possible number. Less possible number to the substituent. So according to first point preference. According to first point of preference. So here we should follow these rules, that is lowest locant, lowest or first point of preference, first point of preference. Next, alphabetical order. Alphabetical order. When we follow the alphabetical order means when substituents have same number. Substituents have same number from either direction. Okay, I will discuss in the examples. Okay, so now let us take some examples and let us try to write the IUPAC name. Okay, first simple alkanes. First we will see the alkanes, then after alkanes, then after alkynes. Carbon, and here CH3, CH, CH2, CH2. So what is the name of this compound? Simple compound I have given CH3. So the numbering first we should select the longest carbon chain. So what is the longest carbon chain here? 1, 2, 3, 4 or 1, 2, 3, 4. So in any direction you are getting the 4. That's why I am taking in this direction 1, 2, 3, 4. And here numbering. So here it is one numbering and this is one. 1, 2, 3, 4. Okay. CH2. CH. Okay. So the which numbering is correct? So in this direction you are getting the third position for the substituent. In this direction you are getting the second position to the substituent. So lowest, according to the lowest locant, we should select this numbering. So what is the name of this compound? Okay, how to write the name of this compound? So here we already know in this type we are having secondary prefix, secondary prefix plus root word plus primary suffix. This is enough, this structure is enough for us. Okay, so now secondary prefix. What is the secondary prefix? Substituent. What is the substituent here? CH3. CH3 means methyl. Okay, what is the name of the substituent here? Methyl. Position. Position is second position, 2. So remember very carefully, when number and name is there means we should separate with the dash, 2 dash methyl, 2 dash methyl, and okay, substituent is finished. Next, root word. How many carbons are there? 4. 1 2 3 4. But, and only carbon carbon single bonds are there, an. Okay, so what is the name of this compound? 2 methyl butane. Okay, next let us take one more compound here. Let us increase some complexity. Carbon, okay, this will become complex substituents. Okay, right. So now this is the organic compound. So now let us select the first one is selection of the longest carbon chain. So which is the longest carbon chain? Okay, count the carbon atoms simply. 1 2 3 4 5 6. 6 carbons here we are getting. 1 2 3, then after 4 5. Here also in this direction also we are getting 6 carbons. Okay, still any other possibility may means from here to here you'll get the same. So that's why 1 2 3 4 5 6. Next, numbering of the carbon chain. Here we are having two substituents, so we should give numbering according to first point of preference. First point of preference is that, so in which direction you are getting the lowest number first, that is only the correct. Okay, so here 1 2 3 4 5 6. So in this direction we are getting substituent at a second position. In this direction we are getting substituent at 1 2 3, third position. So this is only the correct. And remember very carefully, when you are writing the IUPAC name, we should write the, so one more rule here we can add. We should write the name of substituents. We should write the name of substituents. We should write the name of substituents irrespective of, we should write the name of the substituents according to alphabetical order. According to alphabetical order. According to alphabetical order, irrespective of their position. Irrespective of their position. Irrespective of their position. Okay, so that also you remember. Okay, right. Okay, so now what is the name of this compound? So what is the structure here? Like this compounds, secondary prefix, root word, primary suffix. So secondary prefix tells about the substituents. So here this is the substituent, this is also substituent. So what is the name of the substituent? Only one carbon is, that is CH3. CH3, sorry, CH2. CH3 means C2H5. This is the CH3. The name of the substituent is methyl. The name of the substituent is the ethyl. Okay, so which one we should write first? Ethyl. Okay, so for ethyl, next 2 methyl, 4 ethyl, 2 methyl. How many carbons? 6. 6 means hex A. Okay. So this is the name of the above compound, this compound. Next, let us take one more example. Okay. Let us take this example: carbon, 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 carbon. So here CH3, methyl is substituent. Here CH2, CH3. Okay. So now let us number this carbon. Select the longest carbon chain. So which is the longest carbon chain here? That is 1, 2, 3, 4, 5, 6, 7. In this direction we are getting 7 carbon atoms, and 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons we are getting. So this is the longest carbon chain. Okay. Now numbering. Numbering, in which direction we can give the numbering? So this direction. Why? Because here we will get the substituent at second position, but here substituent at which position? Third position. Okay. So now let us take some modifications here to give one more point, that is alphabetical order point. Okay. Carbon, carbon. Okay. So now the longest carbon chain is this one. This is the longest carbon chain. So numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons are there. And when you come from opposite direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so left to right, this is position at 4, 7 position, and right to left, this one, this is the right to left. What is the position of the substituent? Here also 4, 7. So now we are having the same position here also 4, 4, 4, 4, and this is also 7 and 7. Then that time, which numbering is correct? Which one we should give the which one we should select? So here now then we should select the numbering according to alphabetical order. Okay. So here according to alphabetical order, what is the name of this group? Methyl. Means this group starts with the M. And what is the name of this substituents? Substituent ethyl. So this starts with the E. So now which one will come first? Means E. So now which one is the correct? Left, right to left. Right to left numbering is correct. Okay. So now let us name this compound. How to name this compound? Okay. So what is the position of ethyl? Fourth position. So 4 ethyl, 4 ethyl, 7 methyl. Total how many carbons are there? 10. 10 means decane. Okay. So this is about some examples of nomenclature of aliphatic hydrocarbons without any functional group. Okay. So in the next video, I will explain IUPAC nomenclature of aliphatic compounds with complex substituents. Now up to now we have discussed with simple substituents. Again I will discuss with the complex substituents, alkenes and alkynes. Okay. Thank you for watching.